All right, so we're gonna start our intro to logs, and this one is pretty easy. It's not very hard. Okay, so logs seem like they're crazy, but they're not. We're gonna drop down to this right here. You need to know this. If a log has no base when it's written, it's implied that the base is base 10. You need to know that. So log form looks like this. It can be any of those letters or whatever. All right, so I'm going to show you exactly what it looks like in examples and then how to switch forms, and then we're going to talk about how to solve them by switching those forms. So for exponential form, it's going to look like this. Or we're going to flip it around to something like this. We'll talk about it in a minute. So exponential form is what we did yesterday, where we had our y-intercept, our multiplier to the x. Log form is going to have some number in the b and the a, and then it'll be equal to some variable, and that variable can change. It doesn't have to be anything specific. Okay. So if you look at yours where it says underneath the switch forms, there's all kinds, there's y and b, and there's x. It's all the same. So an example would look like this: log base 2 of 4 equals x. And now, if you did anything with logs in math 2, if you did, it was just literally typing it into a calculator. So evaluating logs, log 4, log 5, whatever. And those are all base 10. So the difference in what we're doing now is we're changing the base. Okay. So we're going to learn how to switch forms, and your 3 magic words are right here: left, right, middle. And I'll explain that in just a minute, but I always put it like this. Oh, let me get it in the right order. Ignore that I put that. Take that off there. All right, left, right, middle. That little phrase right there, left, right, middle, will help you through the whole chapter, okay? So if we look at the very first one right here, to change forms, you're literally doing left, right, and middle. So what that means is we're looking at our numbers, and we're looking at the leftmost number. So if we're looking at log 464 equals x, you're not looking at log. We're going to change it from log form into exponential. So log doesn't count anymore because we're trying to get rid of that, okay? What is your leftmost number? 4. Your rightmost is y, and your middle is 64. We're going to do it in that order. So this is what it's going to look like. Left, the right becomes your power. The middle becomes what it's equal to. Left, right, middle. I'm going to do all the ones on top first. I'm going to switch all the logs first, and then we'll do exponentials. Okay. So for the next one right here, log base u of 15 over 16 equals v. Remember, we're trying to get rid of the log. So we're going to do left, right, middle. The left is going to be your base. The right is going to be your power. The middle is going to be what it's equal to. That's literally all you do. It doesn't get any harder than that. It's the same thing when you switch to exponentials, okay? On the next one, log base 7 over 4 of x equals y. So we're trying to get rid of that log. We have left, right, and middle. The left becomes your base, so 7/4. The right becomes your power to the y. And if you need to put it in parentheses, you can do that as well. It doesn't matter. Equals your middle, which is x. So left, right, middle. You're going to have to be able to switch forms. They do ask you to do that. So when we switch from log to exponential, we're trying to get rid of the log. When we go the opposite way, when we go from exponential to log, the first thing that you're going to do is write the word log. You're going to do the same thing, left, right, and your X is the middle, but you want it to look like this up here, okay? So we're going to start with log. The left is going to be your base. So that's a little subscript. The right is going to be the same font size as the log, so the regular number. And then equals the middle, which is X. So the only difference is we're putting the word log. Okay. So on the next one, we're going to write the word log. We have left, right, and middle. The left is going to become your base, log base 1/5. The right is going to become what it is of, so log base 1/5 of y. And then it's going to be equal to the middle, which is X. And again, these are not like this would not be solving right now, something like the one we did in the beginning. That's what we're going to be solving in just a minute, where it only has one variable. So don't freak out. We're just switching forms right now. Okay, nothing to solve yet. We're going to write the word log because we're changing it to log form. We have left, right, and middle. Left becomes your base, so log base B of your right number, 123, equals your middle, which is A. So left, right, middle. All right, so again, in math 2, I'm going to show you on your calculator real fast what you would have done. Now, I realize that some of you took math 2 in the fall of last year, which means you got the full math 2 curriculum, and some of you took it in the spring and you barely got anything at all, okay? So I'm going to go over this. If you already know it, bear with me. When you look at your calculator right beside the 7, there's a log key. This log key is base 10. So if you did anything in math 2 with logs, that's all you did, was you hit the number or you hit the key log and you put in something like 2. That's all you did, okay? So since that's all you did, that's what we're going to start with, all right? So this is called the change of base formula. Change of base formula. And the way I always teach it is when you look at your log, the way I say it, or the way that you should say it, is log base B of A. This is a base. Base goes on bottom. Okay. Or talking about font size, log of the big number font size over log of the small font size. Got it? I don't care how you remember it. A lot of times my regulars remember big over little more than they'll remember B as the base, okay? So when we look at this and we want to evaluate these, you're going to take and write log over log. Make sure you remember which one goes where. The first number goes on the bottom. It's the base. So log 4. The other number goes on top. So log 64 over log 4. And you put that in your calculator, okay? So I like to do what alpha y equals, so I don't have to do parentheses or anything like that. So on the top, I have log, that's beside the 7. So just so y'all see it, log is beside the 7. 64, you can close those parentheses. And then log 4. When we evaluate that, we get 3. And I'm just going to write it at the bottom. That's it. That's all you do. So set up the next one more time. The base or the little number goes on the bottom. And by little number, I mean font size. The big one goes on the top. I do alpha y equals log 1 over 243 log 3. And we get -5. So how would I do the next one? Where does the 2 go? On the bottom. The 4 goes on the top. We put it in our calculator. Log 4, log 2, and we get 2. Is there an easier way to do this? Yes, there is, but this is just tying back into what you guys did yesterday. So what did we do? We made this base 10. There's no base on this log. That means it's base 10. That's what your calculator does. Okay, so that we could evaluate it straight into our calculator. The next one, the 2 goes on the bottom, the 16 goes on the top. We're going to do log 16 over log 2, gives us 4. The next one, like I tell my regulars, it's usually log of big over the little. The big font is 1 over 216. The little is 6. Again, based on the bottom, it doesn't matter how you remember it. Alpha y equals log 1 over 216, log 6 gives us -3. And then the last one, base goes on the bottom, so 5 goes on the bottom, 125 goes on the top. Log 125 over log 5 gives us +3. Pretty simple, right? Not too bad. Okay. All right. So now that I've showed you how to do that, I'm going to tell you that there's a much easier way to do it, and you don't ever have to remember that again. But did I show you how to do change of base? All right, so you know, here's how this works. In your calculator, let's see. Yep. I always go to math. Some people told me some different places, but I always go to math and then go up twice to this word that says log base. Did everybody see that? So math and up twice. And then it puts it in just like this. So if we were doing this log 4 of 64, we're just typing it in. We don't have to worry about any kind of formula. Does that make sense? So I taught you change of base. I don't expect you to use it. Got it? If we look at the next one, math up to, we have 3 of 1 over 243. It already puts the parentheses and everything in for you, so you don't have to do anything. So one more time, math up 2, and you have 2 and 4, and you get 2. Pretty simple, right? Okay, you don't ever have to worry about using change of base. I just wanted to show you. The only thing you need to remember is if it's just log, so let me show you this one more time. If they give you just log 4, it's actually log base 10 of 4. This is what you need to know if they don't put it. It's the same thing as if I give you square root, you know that there's a 2 here, but we don't put the 2 there. Make sense? Same thing. So again, if it's log equals 4, it's log base 10 of 4. All right. So it says solving using simple logs. So it says when a variable is attached to the logarithm, use when the base is raised to the power. We're not even, I don't do swoosh method or evaluating log equals log. I'll tell you exactly what I do. Left, right, middle. Left, right, middle. Okay. So when we look at this very first one, we're going to talk about inverse properties of exponents. So if we have log base A of A, you see how these two are the same? And we set it equal to B. This cancels out and just leaves us with whatever the number is that's left over. So log base A of A will cancel out. If we have base A, let me think about it. To A, so base A to log A, that will cancel out. It'll just leave us with a number, okay? So here's what I'm showing you. In the very beginning, right here, it has log base 6 of 6. You guys see that? Log base 6 of 6. That will cancel out and just leave you with the power. It's that simple. Don't make it harder than what it is. So if we do log base 5 of 5, that will cancel out and just leave us with 2. Or if you have 3 to the log base 3, all of that will cancel out and leave you with what's left over there. Then you just write it down. Same thing on the next one. 4 log 4 cancels out and leaves us with 2x minus 3. Okay. Any questions on that? All right, so here's your simple solving. Here's your simple solving. Left, right, middle. Left, right, middle. So we're going to do left, right, middle. So they're already in log form. So we're trying to get rid of the log because that's what we can't do. So we're going to do left, right, middle, like we did in the very beginning of the note. So your left is 9. You're going to raise it to the power of 2. And we're going to set it equal to the middle, which is n. What is 9 squared? 9 squared, not the square root. 81. That's it. That's how you solve that. Same thing on the next one. We have left, right, and middle. So left is going to be your base. Right is going to be your power. The middle is what it's equal to. Solve this equation. What's 2 to the third? 8. And then how do I solve for x? Divide by -1. It's normal after that. So we get x equals -8. Now, what I haven't done is you need to make sure that when you plug it back in, it does work. You do have to check your logs to make sure. Exponentials, you don't have to check, okay? But if you start with a log, you have to check it. If I plug this 81 in, you got to make sure it doesn't have a negative or a 0 because you can't take the log of a negative or a 0. This one, when I plug -8 in, it's a negative -8 or a positive 8. So we're good. As long as that number is not negative, we're okay. All right, so let's look at the next one. Here's the difference in this one. You have to get that log by itself. So get that log alone or by itself. So on the first two, the problem is we have a 9 right here. So treat this like it is, let me find a piece of paper that you guys can actually see on. Treat this like it's 9x equals 0. How would I solve this? Just divide by 9. It's not a hard question. It's a serious question, okay? Divide by 9. So to get rid of that 9 in front right there, we're going to divide it out so we don't have to worry about it. That leaves us with log base 5 of -9v equals 0. Now it just looks like 1 and 2 because I got rid of that 9. So 1 and 2. So we're going to do left, right, and middle. Left is your base. Right is your power equal to the middle. Be careful on this. A lot of you will try to mess this up on accident, not on purpose. Anything to the 0 power is always 1. Don't forget that. Okay. Anything to the 0 power is always 1. And then how do I finish this out and solve for v? Regular equation. This is not hard. How do I get rid of the -9? So I get v equals -1/9. Again, if I plug it in right here, -9 times -1/9 is a positive number. So as long as I have a positive and not 0, I'm okay. Number 4 is the same exact way. I need to get this log all by itself, so I need to move this 10. How do I move the 10? Same thing we did on the other one. So then my log is by itself, log base 12 of negative b is equal to -1. You're going to switch the form so you can get rid of the log by doing left, right, middle. Your left is your base, your right is your power, and it's equal to the middle. If you need to, use your calculator. Remember, you get your calculator through the whole exam. I don't like decimals when I'm dealing with this, so I'm going to change it to a fraction. And I get 1/12 equals negative b. How do I solve for b? And that just gives you a negative 1/12 equals b. If I plug it back in, a negative times a negative makes a positive, and it's not going to be 0, so we're good to go. What's the difference in number 5 and number 6? Just look at number 5. What's the difference in number 5? What's this have that the other ones have not had? Come on, guys. You can do it. Do it. Yeah, absolutely. I'm not being, it's not hard questions. I promise I'm not trying to like trick you up. Don't freak out because it's simple like math that you're doing right now, okay? So the difference is this 9 right here, this 9 plus. You cannot put the 7 together. Here's what I'm telling you. This is your log right now. You have to get it by itself. How do I get this by itself? It's a 9 plus. So we're going to subtract that 9. That leaves us with 7 log base 11 of r equals 0. Now this problem looks exactly like 3 and 4. What do I need to get rid of now? The 7. How did I get rid of it before? Divide by 7. So log base 11 of r is still equal to 0. Once you get log by itself, left, right, middle. Your left becomes your base. Your right becomes your power, equal to the middle. What do we say? Anything to the 0 power is? Yeah, and if you forget, remember we use our calculator the whole time. We get 1 equals r. If we plug it back in for r, it's a positive 1, so it's good to go. You can't have a negative or a 0 in there. So number 6 is actually the same way. Let me explain something to you, and I'm going to show you on this paper again. There is a difference in these two problems, okay? What this says is this one says this works with the log. All of this is the log together. Y'all understand that? All of that is the log together. When you have something like the question that we're on right now, this is the log together. Make sense? So we got to get rid of that 4. The only time you won't get rid of the 4 is when it's in parentheses. So if they want it with it, they'll put it in parentheses. So the first thing we need to do, just like we had to subtract 9 over here, we got to get rid of this plus 4. So we're going to subtract 4. We get negative log base 11 of x is equal to -3. Now it looks just like 3 and 4. How does it look like 3 and 4? We have a negative in front or a -1 in front. So we're going to divide by -1. And we get a positive log base 11 of x equal to a positive 3. Now that our log is by itself, you're going to do left, right, middle. So left is your base, right is your power, equal to the middle. Put it in your calculator. 11 to the third is 1331. And that's it. That's all you do. All right. So now 7, 8, 9, and 10 are in exponential form. So we got to switch them to log form. Remember how we do that. Write the word log, left, right, middle. Log, left, right, middle. But the thing you have to remember is to get your exponent by itself. All of these are. So what I'm saying is, and I don't know if you'll have one on your homework. I just want to make sure. If you had something like this, everybody see that? You want to get rid of this +4 first because you want it to have just that power by itself. Okay, so always get your exponent or your log by itself. All right, so if we look at this one, we're automatically going into left, right, middle. The way we do that is we write the word log. So change it to log form. Your left is your base. Your right is the big number next to it. Your middle is what it's equal to. Remember, I showed you the hard way to do this, and I showed you the easy way to do it. Let's do it the easy way. So I'm going to put this in my calculator. So math up to log base 2 of 1/8 gives me -3. Now, how do I solve? It's a regular equation. Divide by -3. Then we get x equals 1. These you do not have to plug in and check. They'll all work. Okay, so logs you have to check. Exponentials you do not. And we'll get to some where you're going to have extra solutions. Same thing on the next one. It's in exponential form. We're going to change it to log form. So we're going to do log. Your left is 4. It's going to become your base. Your right is 1. And it's going to be equal to -3a. Remember, we can put this into our calculator. Here so you can see it. Math up 2 times 4 and 1 gives us 0. How do I solve? Divide by -3. And don't freak out, you still get 0, which is perfectly fine. Remember, anything to the 0 power equals 1, so we would have to have 0 there. Right. So what's different about the next one? Yeah, there's 2 powers, right? Where we didn't have that. So I'm going to skip this one for a minute and go ahead and go to number 10. I'm going to go ahead and go to number 10. But I'm coming back to that. All right, so this one just has 1 power. So we're going to go ahead and do the log. Your leftmost is 125. Your right is 625. And we're going to equal it to the power, 2p minus 3. This one is the exact same way as the other ones. We're going to put it into our calculator. Math, log base, 125, 625. And it gives us 1.3, but I can turn that into a fraction and it gives me 4/3. So how do I solve this equation for p? So I'm going to add 3 to both sides, and I'm going to continue on over here. So add 3 to both sides. I get 13/3 equals 2p. And then how do I solve? And if you just keep doing it in your calculator, you're going to be just fine. So I get p equals 13/6. And again, I don't care if you give me decimals or fractions. It's just easier to grade fractions than it is decimals. All right, so what happens on these? When you look at these with 2 powers, you can do it a couple different ways, but the way that I would suggest is try to get the same base. And here's what I mean by that. I'm gonna go back to this sheet of paper for a minute. If we had a 4 and an 8, 2x minus 1, something like this. I have to have the same base to be able to cancel it out like I told you in the beginning. So here's what's going to happen. I can rewrite 4 as 2 to the second, and then I have an x. Okay, 2 squared is 4, right? I can rewrite 8 as 2 to the third, but I still have the 2x minus 1 up there. Everybody see that? When you have the same base on either side, you can mark it out. So this is a little bit premature in these notes, but I just want to show you. I hope you don't have any on your homework. And then you just solve the equation that you see. 2 times x equals 3 times 2x minus 1. So you would just solve that. All right. So if we look at this one, we're going to make it the same base. 32 and 16. I'm going to go ahead and tell you that 16 is like 8 and 2. That really won't help. 2 will work. 4 and 4, but this can't be 4. So you got to pick a base that works for both of them. The only base that works for both of them is 2. If you're not sure, you know 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. There's that one. 2 to the fifth is 32. So 32 is 2 to the fifth, but I still have a 2k up there. We said 16 was 2 to the fourth, but I still have a k minus 2 up there. Then you can mark your 2's out. The powers are the equation that you're solving. So what's 5 times negative 2x? I mean k, sorry. 5 times negative 2k. Negative 10k. Equals, distribute your 4. What's 4 times k? And then 4 times negative 2 is negative 8. Get your k's on the same side. So I'm going to subtract 4k. This is a normal algebra math 1 problem. I get negative 14k equals negative 8. Your last step is to divide by negative 14. If you can't simplify that in your head, just use your calculator. They're both divisible by 2. So positive 4/7. Any questions? All right, so let me look at your, don't go anywhere just yet, because I think that's the end of our notes. No, it's not. We got plenty more. Good, 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 good. I was worried. Change your base on here. Change your base on here. How can I rewrite 64? What do you think? 2 to the 6th. And if you guys look, 2 to the 5th was 32. 2 to the 6th is 64. So this one doesn't have to change because it's already base 2. 64 is going to be 2 to the 6th. And then we're going to mark it out. And we're going to solve 3a minus 3 equals 6. How do I solve that? Add 3. I get 3a equals 9. Last step. And a equals 3. All right. What do you think 125 and 625 can be written as? Yeah, let's try 5. We know 5 squared is 25. 5 to the third is 125. 5 to the fourth is 625. So we're good. And sometimes I have to guess and check like that as well. So that's fine. So 125 is 5 to the third. This looks like negative 2b minus 2. And 625 is 5 to the fourth. There was no power up there. When it's the same base, we can mark it out. And then solve the equation that you see. We're going to distribute the 3. We get negative 6b minus 6 equals 4. And then solve the equation. We're going to add 6 to both sides. We get negative 6b equals 10. Divide by negative 6. And we get negative 5/3. We've already done 13 through 16, putting it in our calculator. Remember that. So math, go up to and do log base. All right, so that's just putting that in. So we're going to skip those 4 because we've already done that multiple times and I don't need to waste your time. All right, so what if it has this? Log and log. You see how it has one log on one side and one on the other. It's just like the power. We had one power of 2 on one side, one power on the other. We got to mark it out, right? Same thing on these. One log on one side, one on the other. We're marking it out. And that leaves us with p minus 9 equals 2p minus 7. I'm going to put your p's on the same side. So I get negative 9 equals p minus 7. Add 7, and I know I'm going quickly through this part, but you guys know how to solve equations, okay? And I get p equals negative 2. These are one of the ones that you have to plug in, and here's what I'm talking about. You're just going to plug into this set of parentheses where the p is, and this set, to make sure that it doesn't give you a negative or a 0. So negative 2 minus 9, what does that give you? Watch this. My log base 2, if I plug it in, negative 2 minus 9, no, that was bad. Sorry, y'all. Negative 2 minus 9. What happens? So this one doesn't work. So this one is actually no solution. I'm glad we got one of those. So if we look at the next one log on one side, one on the other, our equation is 7 minus x equals 7 minus 2x. I'm going to add 2x to both sides. I always move the smallest x to try to make it positive. So I get 7 plus x equals 7. Subtract 7 and I get x equals 0. We're going to plug it in and make sure it's not a 0 or a negative number. So 7 minus 0 is 7. So that one works. It's a positive, not 0. 7 minus 2 times 0. 2 times 0 is 0. 7 minus 0 is 7. So this is your solution. Okay, so plug it in and check it in those two. All right. So 19 and 20 are the pretty much the crappiest problems you're going to do. And I'll tell you why. It's not anything hard. It just takes a long time. So one log on one side, one on the other, we mark it out. But this time we have an n squared and an n. So remember, if you have n squared and an n, you're going to get that together, factor and solve. That's why, that part right there, factoring. So I'm going to add this n to the other side. So I get n squared plus 4n equals 12. We're going to subtract 12 so that we get it equal to 0. Now remember, our factoring said if there's no number in front, we can do the cheater method. I need factors of negative 12 that add to 4. I've shown you how to do that on your calculator, but on this, you shouldn't have to do that. They're going to be negative 6, sorry, positive 6 and negative 2. And then your answers are the opposite signs, negative 6 and positive 2. Last thing you need to do is check. So put them in your calculator. Negative 6 squared plus 3 times negative 6 gives me a positive number, so I'm good there. 12 minus negative 6 gives me a positive number, so 6 works. And then check 2. 2 squared plus 3 times 2, or 12 minus 2. Both of those are positive. It also works. Okay, sometimes none, sometimes one, sometimes both will work. So you got to check them off. And then one more just like that, and we're done. Okay, one more just like that. So mark the logs off. We have negative 5p minus 2 equals p squared minus 8. Since I have p squared and p, I'm going to get it equal to 0, factor, and solve. So I'm going to add 5p, and I'm going to add 2 at the same time, so that I get 0 on this side because these cancel out. I have a p squared, 5p, and then negative 8 plus 2 is negative 6. Cheater method, factors of negative 6 that add to 5. I'm going to show you on your calculator just so you have reference one more time. These are easy ones. You should be fine. We would do negative 6 divide x, negative 6 divide x plus x. Look in your table for positive 5. So your factors are negative 1 and positive 6. Okay, again, just so you can reference that. Your answers are positive 1 and negative 6. And then check to make sure that they work. So negative 5 times 1 minus 2. What happened right there? It gave me a negative. And you guys can check it out if you want to put all that in your calculator. But this one is not going to work. Okay, it's not going to work. If we look at the next one, negative 5 times negative 6 minus 2. That did work. Check your other set of parentheses. Make sure you put the negative 6 in parentheses. Negative 6 squared minus 8 also worked. So the only solution you have to this one is negative 6. Make sure you check them. And which ones do you have to check? What do you, yeah, just the logs. That's what I was asking. So you don't have to check exponential, just logs. All right. So let's look at your quiz real fast just to go over it. The first 4 are just putting it in your calculator. First 8 are just putting it in your calculator. 9 and 10. This is the longest quiz in the world. I did not make it. These, remember, are left, right, middle. They're just changing the form. Not solving, just changing the form. Got it? So all of these will take you like 2 seconds. So the first page is maybe going to take you 3 minutes tops, okay? 11 and 12, again, is just left, right, middle. The next one is rewrite in log. So then it's going to be log left, right equals middle. So left, right, middle. So the first 15, pretty quick, okay? Don't sit here and do nothing. Then 17, remember, we just mark out our logs, set our equation equal to each other, plug in those answers, okay? Same thing on 18, mark your logs out, solve them. Same thing on 19 and 20. When you get to 21, get your logs alone and then left, right, middle. Okay, get your log by itself, then left, right, middle. When you get to 25, remember you're going to do log of the left, right equals middle. These will not take you long at all. On 27, you have the 4s you just mark out. So if they're the same base, mark them out. And remember, I'm recording this, so if you're not getting all this down, you can go back and reference it. Just go back to the end of that. I'll post it in just a few minutes. On this one, left, right, middle. So log, left, right, middle. That's a B. Looks like an H. Sorry. And then just solve that equation. Remember, we can just throw that in our calculator and solve. Okay. So it seems like it's a lot, but it's not going to take you long at all. And that's it. So the ones that will take you the most time are 17, 18, 19, 20, 21, 22, 23, 24. These should not take you long at all. Okay, so 23 through 26. You will be able to get it done. You guys sitting in here can get it done before you walk out. Okay. Everybody else, like I said, I'll post this so you can reference like this quiz at any time. Okay. All right, that's it. I'm going to stop sharing, stop recording.